Okay, number 9 is Matthew. 3 minutes. 3, 2, 1, go.
Hi, I'm a quantum optoelectronic engineer. I'm here to make your money safer. What's not so obvious from my job description is I actually work with light. And light can be used to send messages. Let me take a second to explain this. If today, in the room, we heard a sound like that series of dots and dashes tells me, and anyone who understands Morse code, that someone has received an SMS. And so by flashing light in a sequence of pulses, we can effectively send a message. This is the basic principle of communicating with light, that is using fibers and that powers the internet. In reality though, we use lasers and complex detectors to be able to transmit these messages. I'm working on an optical computer which would be able to send light messages in a more stable and safer way than flashing light through the air or with a fiber. Let's take a step further and think about an optical chip which would be able to use one single pulse of light, or a photon. At this point, we start having strange behaviors which are described by quantum sciences. But what does this look like? Well, light can be polarized, either vertically or horizontally. Now, a photon can be in both of these states at once. And so actually from one photon, we have 2 bits of this so-called quantum information. And so the amount of quantum information grows faster than the number of our photons. And actually, if we have a situation with a large number of identical photons, the interactions governed by quantum mechanics become exponentially complex and sensitive. They are so sensitive that you would actually be able to see if someone is trying to look at your light message. So I build optical chips for quantum computers, such as the chip that you can see up on the screen. And these will be able to process quantum information. They are made out of silica glass and are about the size of a stamp. The rainbows that you can see are the wires which will be able to move the optical information through our circuits, and the filters to select the correct signals and manipulate this information. So far in my work, I've been able to show a filter for polarization which approaches the performance of commercial devices. And this could be one of the first set of building blocks towards a quantum computer. The technology that I am working on is really looking at manipulating up to 20 individual pulses of quantum information and trying to reach computing complexities which are going to help us solve extremely complex problems. Now, this is interesting because we can further our understanding of cryptography and coding for secrets, which is of particular interest if you want to be able to send private information, such as your bank details, over a channel. And in doing so, I hope you'll be able to protect your bank details and keep your money safer. Thank you for your attention.